Section R.3, addition, subtraction, and multiplication of polynomials. Okay, terms. Definition. A term is any algebraic expression that involves only multiplication and or division. So notice, no addition or subtraction is allowed in terms. So that means that terms are the expressions between plus and minus signs. So in order to identify a term, just find where your plus and minus signs are. If you see a plus or a minus sign, that's the end of one term and the beginning of another. The minus sign actually belongs to the term that follows it. It's what makes the term negative. Some examples of terms. All numbers are terms. They're called constant terms. Okay, numbers are also called constant, and since they're terms, that's where we get the name constant terms. Then x, 4x, 11x, negative x, and so forth. Those are terms. They're called x terms. If we replace all the x's with y's, then they would be called y terms. In general, if there is just one variable and it is exponent of 1, then they are called linear terms. So linear terms is the more general name when you don't know the variable and the exponent is 1. And stuff like x squared, negative 6x squared, negative x squared, and so forth, they're terms. They're called x squared terms. If we replace all the x's with y's, it would be called y squared terms. In general, if there is just one variable and an exponent of 2, then they are called squared terms. Okay, hopefully you're seeing the pattern that's going on here. Okay, similar for other terms. The variables in the term give the term its name. This leads to, a definition. We've actually used the word before, but we're now going to make it formal. Definition. The nonverbal part of a term is called its coefficient. Okay, so the nonverbal part is basically the number. The variable is actually given the term its name. So basically the coefficient of a term is the number part. Okay, the coefficient does include a minus sign if there's a minus sign in front of the term. So some examples. Let's identify the coefficient of each term. There has to be a coefficient. So if you say there's no coefficient, something is wrong. So there are 6 examples. Now remember, the coefficient is the non-variable part of the term. It's basically the number. So for our first one, negative 7x cubed y to the 11th. Okay, the x cubed y to the 11th, that's the variable part. So the negative 7 has to be the coefficient. For number 2, x to the 7th y z squared, those are the variables. So 14/3 is the coefficient. For number 3, there is no variable part. So the constant term is its own coefficient, negative 78. That's going to be true for any constant term. It is its own coefficient. For number 4, I have x squared y. Remember, according to the identity property, secretly sitting out in front of this is the number 1. So if you don't see a coefficient with the variable, it's understood to be 1. Negative x, remember that's really negative 1 times x, so its coefficient is negative 1. And then I have 4.76 x squared y. Again, those are the variables. So the 4.76, that's the coefficient. Okay, remember, the coefficient is the number part of the term. For a constant term, it is its own coefficient. If you don't see a coefficient, it's understood to be 1. If you just see a minus sign, like number 5, it's understood to be negative 1. Now that we know what terms are, let's get to polynomials. Definition. Number 1, a monomial, the prefix mono meaning 1, is a single term in which no variable appears in the denominator. All variables of exponents are natural numbers, and no variable appears as part of a special function like absolute value, square root, and so on. So loosely speaking, a monomial is one nice term. Number 2, a binomial is the sum or difference of 2 monomials, the prefix bi meaning 2. So it's 2 nice terms. Number 3, a trinomial is the sum or difference of 3 monomials, the prefix tri meaning 3. A quadrinomial, the quad meaning 4, is the sum or difference of any 4 monomials. And in general, a polynomial is the sum or difference of any number of monomials. So the polynomial is a more general phrase. Anything that's a monomial, binomial, trinomial, quadrinomial, so on, those are polynomials. So let's get some examples. Number 1, all numbers are monomials. They kind of satisfy the definition in a vacuous way. They don't have any variables, so we don't have to worry about variables being in denominators or their exponents. All the restrictions for polynomials are on the variables. Number 2, x, 8x minus 5x, 12x squared, 14x squared, y to the 5th c, so on. Those are monomials. They're just one term. Then x minus 6y, x plus 2, x squared plus 7, x to the 32nd minus 6y cubed. These are binomials. They have 2 terms, separated by plus or minus sign. So this one consists of an x term and a y term. This has an x term and a constant term, an x squared and a constant term, and so on. Then these guys, x minus 6y plus 3z, 2x plus y minus 6, x squared plus 5x minus 11, x to the fourth minus 7x cubed plus 1, and so on. They have 3 terms. Those are trinomials. Then these guys have 4 terms. 3x plus y minus 8z plus 10, 3x cubed minus 8x squared plus 7x minus 2. Those are quadrinomials. They have 4 terms. And all of the above are in fact polynomials. Anytime you say something is some sort of an omial, they are polynomials. Okay? So remember, numbers are polynomials because they satisfy the definition in kind of a vacuous way. So you just count how many terms you have, and that will give it its special name. Usually after quadrinomial, we don't give them a special name, we just say polynomial. Let's look at some things that are not polynomials. So the following are not polynomials. We're going to try to figure out what part of the definition did they fail. Okay, number 1, the absolute value of x minus 5. What's wrong with this is we have an x inside of absolute values. Remember, no variables are inside of these special functions. It's okay for a number, but not for the variable. Number 2, I have 3x to the 1/2. Okay, this fractional exponent, remember, that's not allowed on the variables. It's okay if it was on the 3, but it can't be on the variable. Remember, the exponents in the variables must be natural numbers, or at worst whole numbers. We will allow 0, but remember, anything with the 0 power is really 1. And number 3, 3 over x. Can't have variables in the denominator, so that's not allowed. It's not a monomial, but it is a term. Okay, all of these things are in fact terms, but they're not polynomials. And number 4, square root of 3x. Okay, the x is in fact under the square root. That's not allowed. It's okay if the 3 is, but not the x. So it's not a polynomial because of the square root being capturing the x. Hopefully you're catching on to what is a polynomial and what is not a polynomial. Degrees. Definition number 1. The degree of a monomial is the sum of the exponents on the variables in the monomial. And remember, the exponents on the variables are natural numbers. You're just adding up the natural numbers. So the degree is always going to be a natural number. Now remember, a polynomial is made up of a bunch of monomials. Each one of those monomials has a degree. So number 2, the degree of a polynomial is the degree of the monomial with the largest degree in the polynomial. Now, if there's a tie for first place, we really don't care about which term is giving the degree for the polynomial, but we look at the largest degree of the monomial. Excuse me. Some examples. We're going to find the degree of each polynomial. Remember, we have to find the degree of the monomials first. So here's our first one. We've got 3x squared y to the 6th minus 8x to the 5th y cubed plus 11x to the 7th minus 12y to the 4th plus 4x minus 16. Okay, underneath each term, okay, I'm going to write the degree of that monomial. So again, here's our problem. Remember, the degree of the monomial, you're adding up the exponents on the variables. So for the first term, 2 plus 6, that's 8. For the second term, 5 plus 3, that's also 8. Okay, this one just has one variable, that degree is 7. One variable, degree is 4. Okay, for this, remember, if you don't see an exponent, it's understood to be 1. Okay, now there is no variable. Simply sitting next to the 16 would be like x to the 0, y to the 0, and so on. So any variable that sits here actually would have an exponent of 0, because anything to the 0 power is 1. So a constant term has degree 0. All constant terms, except for 0, have degree 0. The number 0 does not have a degree. It's the only polynomial that doesn't have a degree. So there are the degrees of each of our monomials. We look for the one that's largest. Okay, it's 8. There's a tie for first place, but the largest one is 8. So remember, now all numbers except for 0 have degree 0. The number 0 does not have a degree. So keep that in mind. All numbers except for 0 have degree 0, and the number 0 does not have a degree. Its degree does not exist. So the degree of this polynomial is going to be 8. Number 2. We have this rather interesting polynomial, 4x to the 7th y squared z squared minus 8xy z cubed plus 11x to the 12th z minus 13y squared z to the 5th minus 8x plus 10. Okay, once again, we're going to write the degree of each monomial underneath that monomial. Remember, to get the degree of the monomial, just add up the exponents on the variables. So let's see, 7 plus 2 plus 2, that's going to be 11. 1 plus 1 plus 3, 5. 12 plus 1, 13. 2 plus 5, 7. I have just a 1 for the exponent we don't see. And again, all constant terms have degree 0. The largest one is 13. So the degree is 13. Number 3. I have 4x cubed minus 7x squared plus 11x plus 13. Okay, there's just one variable. When there's just one variable, it's kind of easy to spot the degree. It's the largest exponent. So again, if we write the degree under each one, 3, 2, 1, 0. The largest one is 3, so the degree is 3. So again, note when there's just one variable, the degree is the largest exponent. Degrees are kind of easy to find. The problem is, what is the big deal about them? It does turn out when there's just a polynomial with one variable, the degree does tell you a lot about it. When you have several variables, it's just kind of a fun thing to find. Adding and subtracting polynomials. Okay, so we're looking at a generalization of addition and subtraction. Adding and subtracting polynomials is sometimes called combining similar terms or collecting like terms. Similar terms or like terms are terms that have the same name, like constant term or x term or xy terms. Remember, it's the variables that give you the term's name. So the idea is to add or subtract the coefficients of the like terms while keeping the variables. It's kind of like in first grade when you're told you have 2 apples, Johnny gives you 3 apples, so you have 5 apples. In algebra, we would say 2a plus 3a is 5a. So some examples. Perform the unique operations and simplify. Here's our first one. We've got 4x minus 7y plus 12 plus 3x minus 8y minus 14. Okay, just like it's easier to add numbers when they're in a column, it's easier to add polynomials if they're in a column. So I'm going to write it in a column and line up my similar terms. So I'm going to arrange polynomials in column, lining up similar terms. X's under x's, y's under y's, constants under constants. Okay. Now, if you want to put the plus sign, that's fine, but I'm adding. So it's kind of like I got 4 x-rays, someone gave me 3 more x-rays, I have 7 x-rays. Okay, minus 7y, minus 8y, again, just add the coefficients. Negative 7, minus 8, negative 15y. Don't lose the sign. Then 12 minus 14, you get negative 2. So your answer is 7x minus 15y minus 2. Now, if a term adds up to be 0, if the terms adds up to be 0, just don't put a 0, just leave it blank. Now, if they're all 0, you got to put down at least one 0, otherwise it looks like you didn't do the problem. Number 2, we've got 4x minus 8y plus 3z minus 12 plus 9x plus y minus 8. Okay, notice this guy doesn't have a z term, so when I line up my terms, I'm going to leave a space where the z term would go. So here's my space. Now, if you want to put 0z, that's fine, but I don't put 0z because it looks like the word Oz. Okay, now let's add up our separate terms. 4x plus 9x is 13x. Remember, the coefficient you don't see is 1. So minus 8y plus 1y would give you minus 7y. Okay, 3z plus 0 is just plus 3z. Minus 12 minus 8 minus 20. And that's your final answer. Number 3. We've got 6x minus 12y plus 5z minus 5. We're going to subtract from that 11x plus 13y minus 12z minus 7. Okay, we're subtracting this time. So to do the subtraction, the minus sign between the two sets of parentheses, that one, forces us to change all of the signs of the terms in the second set of parentheses. Okay, so we're actually distributing a negative 1. So I'm going to attribute this minus to each one of those terms. Okay, after we change the sign of all these terms, we do what the signs say. So 11x became minus 11x, plus 13y became minus 13y, minus 12z became plus 12z, minus 7 became plus 7. So this minus sign forced these sign changes. Now do what the signs say. 6x minus 11x minus 5x. Negative 12y minus 13y minus 25y. 5z plus 12z plus 17z. Negative 5 plus 7 plus 2. And that's your final answer. Number 4. We've got 5x cubed minus 7x squared minus 8x plus 4. We're going to subtract from that 3x cubed minus 9x plus 11. Okay, again, this minus sign forces us to change all those signs right there. So that became minus 3x cubed, that became plus 9x, that became minus 11. I left a space for the missing x squared term. Now do what the signs say. 5x cubed minus 3x cubed, 2x cubed. Negative 7x squared added to 0 is negative 7x squared. Minus 8x plus 9x is plus 1x. Now don't write the coefficient 1. Remember, 1x is just x, the identity property again. 4 minus 11 is minus 7. And that's your final answer. 5. Okay, we're adding up 3 polynomials. So I've got 5x cubed minus 7x squared plus 11x plus 3 plus 2x cubed minus 8x squared minus 9x plus 3, and subtract from all that x cubed minus 5x squared minus 2x plus 4. Now again, this minus sign is going to force us to change all of those signs. So let's put the column, line up our powers of x, and make the sign changes. Did I change my signs correctly? Minus x cubed plus 5x squared plus 2x minus 4. Okay. Now let's start adding up our coefficients. For the x cubed, 5 and 2 is 7, minus 1 is 6, 6x cubed. For the x squared, minus 7 minus 8 is negative 15, plus 5, negative 10x squared. For the x, 11 minus 9 is 2, plus 2 is 4, plus 4x. And for the constant, 3 and 3 is 6, minus 4, plus 2. That's our final answer. Okay, we have one more. We've got 5x minus 7y plus 3z plus 12. Subtract from that 8x plus 4y minus 3z minus 2, and then add 2x minus y minus 4z plus 3. Okay, here the minus sign is in front of the middle polynomial, so all of these signs will change. So let's write the column lining up our similar terms. Did I change my signs? Negative 8x minus 4y plus 3z plus 2. Yes. Okay, starting with the x. 5 minus 8 is negative 3. Negative 3 plus 2 is negative 1. So negative x. Again, don't write negative 1x. It's not simplified. Minus 7 minus 4 is minus 11. Minus 1 is minus 12y. 3 and 3 is 6. Minus 4 plus 2z. 12 plus 2 is 14. Plus 3 is 17. And that's our final answer. We're now going to look at multiplying polynomials. We're going to do it in steps. Okay, now remember, numbers are polynomials, so the simplest step would be a number times a number. We're not going to start there, so we're going to start with a monomial times a monomial. We've actually already seen this, the monomial times a monomial. We've actually seen it in a more general setting. So this is really just a simpler form of working with exponents. Remember, when we worked with exponents, we were allowed negative exponents, we were allowed exponents in the denominators. Monomials don't do that. They only allow positive natural numbers on the exponents. They do not put variables in the denominator. So it's always going to be the first law of exponents. Add the exponents of like base. So find each product and simplify. Here's our first one. I've got 5x squared, y to the 7th, times negative 7x to the 8th, y z squared. Now remember, we've seen this before. You're going to multiply the coefficients, and you'll add the exponents of like base. So to multiply the coefficients, I get negative 35. And when I did the x's, 2 plus 8 gave me 10. For the y's, 7 plus 1 gave me the 8, and z squared was all by itself. So it really is something we have seen before. We've seen it in a more general setting. Number 2, we have 5x cubed y to the 7th times 3x z to the 9th minus 4x to the 4th y squared z. Okay, again, add the exponents of like base and multiply the coefficients. So the coefficient, 5 times 3 is 15, times negative 4 gives me negative 60. When I do the x, 3 plus 1 is 4. 4 more gives me 8. For the y, 7 plus 2 is 9. For the z, 9 plus 1 gives me 10. Okay? So we've actually seen this before. So let's move on to the next step. Monomial times polynomial. We've actually seen this before as well. So this is really just a fancier version of the distributive property. When we did the distributive property, we just had a number outside the parentheses. Now we can have any old polynomial outside the parentheses. So find each product and simplify. Here's our first one. 4 times 3x squared minus 7xy plus 5y squared. Remember, this 4 distributes to each one of those. So I'm going to multiply the coefficients, right? So 12x squared minus 28xy plus 20y squared. So do the first term. There's my 12x squared. Second term, minus 28xy. And the last term, plus 20y squared. And that's all we can do. the order in which you write it, try to keep the same order that was in the parentheses. Also, the number of terms in your answer should be the number of terms that was in parentheses. If not, that meant some terms combined, or else you've lost some. Or you maybe made some up if you have more terms in your answer. Number 2, I have 3x cubed times 6x squared minus 7x plus 11. Okay, so this time we're going to be multiplying coefficients and adding the exponents of like base. So when I do the first, 3 times 6 gives me 18, and for the x, 3 plus 2 is 5, so 18x to the 5th. For the next term, 3 times minus 7 is negative 21, and for the power of x, 3 plus 1 is 4, so minus 21, x to the 4. Then 3 times 11 is 33, and x cubed just comes along for the ride. So 33x cubed. There's our final answer. And let's try one more. We've got negative 3x squared y to the 4th times negative 5x cubed y plus 3xy squared minus 6x plus 12y minus 3. Again, you'll be multiplying the coefficients and you'll be adding the exponents of like base. So when I start off here, see, negative 3 times negative 5 gives me 15. For x, 2 plus 3 is 5. For y, 4 plus 1 is 5. So 15x to the 5th, y to the 5th. The next term, 3 times negative 3 is negative 9. For x, 2 plus 1 is 3. And for y, 4 plus 2 is 6. So negative 9x cubed, y to the 6th. Next term, negative 6 times negative 3 is 18. Then x, 2 plus 1 is 3, and y to the 4th comes along. So plus 18, x to the 3rd, y to the 4th. 12 times negative 3 is negative 36. There is no x, so I have x squared, and 4 plus 1 is 5, y to the 5th. Okay, no variable here, but negative 3 times negative 3 is 9. So plus 9x squared, y to the 4th. And that's all you can do. Let's go to the next step. Binomial times binomial. Okay, this is something that most people, they've seen it before, and usually if they've seen it before, they never forget it. This is FOIL. Okay, it's FOIL. FOIL is an acronym. The F stands for product of the first terms. O is equal to product of outer terms. I is equal to product of the inner terms. L is product of last terms. So it's first, outer, inner, last. And in that order. First, outer, inner, last. It's not first, last, outer, inner. It's first, outer, inner, last. So the picture of FOIL. Here's my general binomial times the general binomial. The A and the B and the C and the D will be numbers that I'll give to you. So if I do the first, I'll have AC x squared. If I do the outer, I'll have ADX. If I do the inner, BCX. And the last, I'll have BD. Okay. Notice the outer and inner, ADX, BCX, they're similar terms. In general, that doesn't have to happen, but for the really good FOIL problems, it will happen. So the outer and inner will combine. So some examples. So find each product and simplify. It is just FOIL. Now please, when you write the answers to your FOIL problems, write them in correct order. Write them in the order of first, outer, inner, last. It's important for what comes after FOIL. So starting with the first one. If I do the first terms, x times x, x squared. I do the outer, minus 6x. Do the inner, plus 8x. Do the last, 8 times minus 6, I get negative 48. Okay, notice the outer and inner will combine. That's the simplified part. So minus 6x plus 8x is plus 2x. So x squared plus 2x minus 48. Write it in that order. Don't write x squared minus 48 plus 2x. It's first, outer, inner, last. This is called the middle term. It belongs in the middle. Number 2, if I do my first, 12x squared. When I do my outer, minus 21x. When I do my inner, minus 32x. When I do my last, plus 56. The outer and inner will combine. See, minus 21 minus 32, I get minus 53x. So 12x squared minus 53x plus 56. Again, write them in this order. Don't put the x term on the last. Notice the powers of x are going down. 2, 1, 0. Number 3, 2x times 3x plus, gives me 6x squared. The outer, 8xy. The inner, minus 21. Okay, technically it's yx, but yx is xy, right? Commutative property. So minus 21xy. And the last, minus 28y squared. The outer and inner will combine. 8 minus 21, I get negative 13. So 6x squared minus 13xy minus 28y squared. Notice as the powers of x go down, the powers of y go up. Middle term in the middle. Do not put this term on the end. The middle term in the middle. Number 4. A to the third times a to the third. Remember, add the exponents. 3 plus 3, I get 6. A to the sixth. Outer plus 9a cubed. The inner minus 8a cubed. The last minus 72. The outer and inner will combine. 9 minus 8 gives me 1, so I have a to the sixth plus a cubed minus 72. And remember, don't write the coefficient of 1, the identity property again. Number 5, the first, I get 5x to the fourth. The outer, minus 30x squared y. The inner, minus 8x squared y. The last, plus 48y squared. Outer and inner will combine. Minus 30 minus 8, I get minus 38. So 5x to the fourth, minus 38x squared y, plus 48y squared. Our last one. 15p squared q squared. When I do the first, plus 27pqt. When I do the last, minus 5pqt. Excuse me, that was the inner, wasn't it? Now I'm doing the last. Minus 9t squared. Outer and inner will combine. 27 minus 5, I get plus 22. So 15p squared q squared plus 22pqt minus 9t squared. Remember, it's first, outer, inner, last. Outer and inner combine to give you a middle term. But remember, they don't have to. So remember, it's first, outer, inner, last. Remember that order. Some special products. We look at some special products with binomials. And remember, when you multiply binomials, it's FOIL. So the formulas will come from FOIL. So if you can't remember the special products, you should at least remember FOIL. You got to remember something. So FOIL is probably worth remembering. First special product, squaring a binomial. So I have for part A plus b being squared. Remember, this exponent means it's a plus b times a plus b. This is now a FOIL problem. When you do the first, a squared. When you do the outer, plus ab. When you do the inner, okay, technically against BA, but remember BA is AB, commutative property. And when you do the last, you get plus b squared. Okay, now like all the good FOILs, the outer and inner will combine. This is 1ab plus another ab gives me 2ab. So I have a squared plus 2ab plus b squared. The other special product is a minus b being squared. And remember, this would equal a minus b times a minus b. It's another FOIL problem. When you do the first, a squared. When you do the outer, minus ab. When you do the inner, it's minus ba, but again, ba is ab. When you do the last, minus times minus is plus, so you get plus b squared. Once again, the outer and inner will combine. Minus 1ab gives you minus 2ab. So a squared minus 2ab plus b squared. Notice they look very much alike. Okay? Their final answers look very much alike. The only difference is the sign in the middle. And notice the sign in the middle is the sign that's in the middle of the problem. So the quick and dirty way to square a binomial. So we're looking at those two, a plus b squared equaling a squared plus 2ab plus b squared, and a minus b squared equaling a squared minus 2ab plus b squared. So here's our quick and dirty way. Step 1, square the first term. Okay, the first term of each problem was a. The answer is a squared, so you're squaring it. Notice that means multiply the exponents by 2, and of course you would have to square coefficients. Number 2, twice the product of the two terms. Okay, in the a minus b, the second term really is negative. So a times negative b is negative ab, and double that. So notice they both have a 2. Remember, the sign of the middle term matches the sign of the problem. And then step 3, square the last term. Okay, the last term and the first term are both positive. The middle term has the sign that was in the problem. Okay, the first and last term are always pluses. And please don't change the order. I have no idea why students do that, but please don't change the order. Products of conjugates. Okay, definition. The binomials a plus b and a minus b are called conjugates of each other. So conjugates are the same two terms, but the sign of one of them changes. We always say it's the sign of the first one that changes, but it could be either one. Now, if both signs change, that's actually opposites. So conjugates just change the sign of one of them. So we're going to say that it changes the sign that separates them. We want a formula for the product of two conjugates. So I've got a plus b times a minus b. Notice it's a FOIL problem. So if you do your first, a times a is a squared. You do your outer, a times negative b is minus ab. If you do your inner, b times a is plus ba. But remember, ba is ab. When we do your last, plus times minus is minus, and b times b is b squared, so minus b squared. If I look at my outer and inner, minus 1ab plus 1ab, it's 0. We don't write the 0, so I just end up with a squared minus b squared. So notice that there is no middle term. Okay, don't write plus 0ab. There is no middle term. The fact that the products of conjugates does not have a middle term will be taken advantage of later. It's taken advantage of later in chapter R, in fact. The answer is called a difference of squares. It will always be a difference. So when you multiply conjugates, you get a difference of squares. Something squared minus something squared. Okay, difference of squares. So the products of conjugates will always lead to a difference of squares. So a plus b times a minus b is a squared minus b squared. So it's the first term squared minus the second term squared. Okay, remember, squaring with exponents means multiply the exponent by 2. For the coefficients, you actually do have to square the coefficients. Let's look at some examples. Okay, we're going to find each product and simplify. Write your answers in correct order. That means put the middle term in the middle. So here's our first one, x plus 6 squared. Okay, now if you can't remember how to square a binomial quickly, remember it is x plus 6 times x plus 6. But if we square it quickly, square the first term. Okay, you're going to keep that sign that's in the middle. So we're going to have a plus. Okay, I want to do twice the product. The product is 6x, double the 6, plus 12x. Okay. And then we square the last term. 6 squared is 36. Again, if you have to actually write x plus 6 times x plus 6 and FOIL it out, that's fine. It will give you the correct answer. It really doesn't take you a whole lot longer. Number 2, I have 5x minus 7y being squared. So again, we're squaring a binomial. So remember, square the first term. 5x being squared is 25x squared. Again, don't forget to square the 5. Okay, now I want twice the product. Okay, we keep the sign in the middle, so it's going to be a minus. Okay, the product is 35xy. Double the 35, I get 70. So minus 70xy. And then we square the last term. Okay, 7 squared is 49, so plus 49y squared. Remember, the first and the last term are always positive. The middle term has the sign of what's in the middle of the problem. And again, write it in that order. Put the middle term in the middle, not on the end. Number 3, we've got 2x squared minus 3y being squared. So again, we're squaring a binomial. Okay, we're going to square the first term. Don't forget to square the coefficient of 2, so I'm going to have 4x to the fourth. Okay, I want twice the product. We're going to keep the sign minus. Okay, 2x squared times 3y is 6x squared y. Double the 6, so I'm going to get minus 12x squared y. Remember, the sign of the middle term has the sign of what's in the middle in the problem. And then square the last term. Okay, 3 squared is 9, so I'm going to have plus 9y squared on the end. And that's our final answer. Again, keep the middle term in the middle. I cannot stress that enough. I have no idea why students put it on the end. It belongs in the middle. That's why it's called the middle term. Number 4. I have 3x plus 2y times 3x minus 2y. It's actually conjugates, but suppose you don't notice conjugates. Hopefully you're at least noticing FOIL. So, if you do the FOIL, I get 9x squared. If you do the outer, minus 6xy. If you do the inner, plus 6xy. And when you do the last, minus 4y squared. Outer and inner add up to be 0. So I'm just having 9x squared minus 4y squared. Doing a conjugate by FOIL really isn't that much longer. Number 5. I've got x squared plus 9y times x squared minus 9y. Again, it's conjugates, but suppose you don't notice conjugates, you're going to do FOIL. So x squared times x squared gave me the x to the fourth. When you do the outer, minus 9x squared y. When I do the inner, plus 9x squared y. When I do the last, minus 81 y squared. Okay, the outer and inner, minus 9 plus 9, 0. There is no middle term. I just have x to the fourth minus 81 y squared. Okay, now we look at the ultimate of multiplying polynomials. Any old polynomial times any old polynomial. It's kind of like everything else we did before was a special case of this. Okay, all I'm going to really do with this is I'm going to show you kind of a good bookkeeping way, so that way you don't lose anything in terms of your multiplication and or combining similar terms. So this is really just the distributive property and combining similar terms several times. So we just need kind of a nice way of doing this. Polynomials in one variable are supposed to remind you of large numbers, so this should somehow remind you of multiplying like large numbers together. So perform the operations and simplify. Write your answers in correct order. If you follow this little nice bookkeeping way, the correct order will happen all by itself. So we're going to take a look at a couple of them. So here's our first one. I've got 3x minus 7 times 4x squared minus 2x plus 3. So I've got a binomial times a trinomial. Okay, now whether it does or it doesn't, it's supposed to make you think of 37 times 423. So we will first do 3x times each term of the trinomial. So I'm going to distribute 3x to each one of these terms. So I'm going to get 12x squared minus 12x cubed, right? 1 plus 2 is 3. Then minus 6x squared plus 9x. So this comes from 3x times each one of those terms. Okay, I'm now going to go to this next line, and I'm going to distribute minus 7. So we go minus 7 times each term. And I'm going to line up the similar powers of x, because notice, it's going to start off with negative 28x squared. So it's going to line up under the x squared term here. So let's do that on the next slide. So I'm going to have negative 28x squared plus 14x minus 21. The x will line up here, the 21 will sit here by itself. So again, the negative 7 distributed to each one of those terms gave me this line. And now we just combine similar terms. So now if we're actually doing numbers, 3-digit times a 2-digit, the indenting that we have here would actually be on the right hand side. So now we're getting ready to combine some terms. So I have 12x cubed minus 34x squared plus 23x minus 21. And there's your final answer. Okay, so again, it's just kind of a good bookkeeping way. You could actually do this with multiplying binomials if you wanted to. I believe our book actually has a few examples of doing that instead of doing FOIL. So let's take a look at a trinomial times a trinomial. So I've got 2x cubed minus 3x plus 7 times 3x squared plus 6x minus 8. Now going back to this one, each one of these lines before I get an answer is called a partial product because it's part of the final answer. So when I do a trinomial times a trinomial, I should have 3 partial products. So the first thing we're going to do is I'm going to distribute 2x squared times each term of the second trinomial. So I'm going to have 6x to the fourth plus 12x cubed minus 16x squared. Now we're going to do negative 3x times each one. Okay, and notice when I do negative 3x, it's going to start off with negative 9x cubed. So it's going to line up under the x cubed. So I should have negative 9x cubed minus 18x squared plus 24x. So that's distributing negative 3x to each one of those terms. Okay, my minus sign really should be closer to the 9. So minus 9x cubed minus 18x squared plus 24x. So now we're getting ready to do 7 times each one of the terms of the second trinomial. Notice when I distribute 7, it's going to start with 21x squared. It's going to line up with the x squares. So I should have 21x squared plus 42x minus 56. And now we're getting ready to combine similar terms. So 6x to the fourth plus 3x cubed minus 13x squared plus 66x minus 56. Now again, just be very careful with lining up your powers of x. Don't make any careless arithmetic errors. And that's the end of section R.3.